China's plan to dominate AI hardware has the US on edge, and for good reason. In August 2023, a phone appeared in China that wasn't supposed to exist. The Huawei Mate 60 Pro, powered by a chip the entire Western world said was impossible to make. This wasn't just a phone launch. It was proof that America's $150 billion strategy to cripple China's AI ambitions had failed. That's more than the entire GDP of Hungary. You heard that right. The US spent the economic output of an entire nation trying to stop China, and it didn't work. What you're about to discover is how China shattered every assumption, and why the AI race just took a turn no one saw coming. But to understand how China pulled off the impossible, you need to see how the US built what looked like an impenetrable wall. The blockade. 2019. The United States makes a move that will reshape the global technology landscape. They pressure the Netherlands to block ASML, a Dutch company you've probably never heard of, from selling its most advanced machines to China. And this wasn't just any equipment. ASML manufactures extreme ultraviolet lithography machines, the only technology on Earth capable of making cutting-edge computer chips below 7 nanometers. Each machine costs $200 million. That's the price of 2 F-35 fighter jets. You heard that right. Building advanced chips requires equipment as expensive as a fleet of stealth aircraft, and ASML has a complete monopoly. No other company in the world can make them. For China's semiconductor industry, this was a death sentence. Their leading chip maker, SMIC, had been desperately waiting for these machines. Without them, Chinese engineers would be locked out of the technology powering everything from smartphones to artificial intelligence. The logic was simple. No EUV machines means no advanced chips, which means no AI supremacy. The wall was going up, but the US wasn't finished. 2022, another ban drops. This time, NVIDIA, the company that makes the processors running every major AI breakthrough, gets barred from selling its A100 and H100 chips to China. These aren't just any chips. They're the most powerful AI training accelerators ever built. OpenAI used them to create ChatGPT. Google used them for Gemini. Every AI lab racing to build artificial general intelligence depends on them. And now China couldn't buy a single one. Then came October 2023. President Biden expands the restrictions even further. This time, the ban includes chip design software and manufacturing equipment. The strategy was now complete. Deny China the tools to make chips and deny them the finished chips themselves. Strangle the supply from both ends. Western experts watch this unfold with confidence. This will set China back a decade, they said. Some claimed it was impossible to make advanced chips without EUV technology. Others predicted China would be stuck manufacturing 14-nanometer chips while the rest of the world raced ahead to 3 nanometers. You were watching the United States construct what appeared to be an airtight technological blockade. Every door locked, every window sealed. But here's what those experts didn't know. The wall already had cracks. The impossible breakthrough. August 2023, just 10 months after Biden's expanded restrictions. Huawei, the Chinese tech giant that had been battered by sanctions, quietly releases the Mate 60 Pro. No press conference, no grand announcement. The phone just appears in stores across China. Tech analysts get their hands on it within days. They tear it apart, examining every component, and what they find stops them cold. Inside is a Kirin 9000S chip, a 7-nanometer processor. Some evidence suggests even more advanced 5-nanometer capabilities. The chip was manufactured by SMIC, the same Chinese company that had been denied access to ASML's EUV machines. You need to understand what this means. SMIC just produced cutting-edge chips without the technology the entire semiconductor industry said was required. It's like watching someone build a skyscraper without a crane. The physics shouldn't allow it. The economics shouldn't make sense. But there it was, running in millions of phones. Western semiconductor experts scrambled to explain how this was possible. Some claimed it was a fluke. Maybe SMIC had stockpiled old equipment before the bans took effect. Others suggested the yields were so low it couldn't be commercially viable. They were grasping for explanations because the alternative was too unsettling. China had found a path no one thought existed. Here's how they did it. SMIC used a technique called deep ultraviolet multi-patterning. Instead of using EUV's single exposure to etch microscopic circuits onto silicon wafers, they ran the same wafer through their older DUV machines multiple times. Each pass added another layer of detail. It's brutally inefficient. The yields are lower, the cost per chip is higher, but it works. And works is all that matters when you've been cut off from the alternative. The timeline made it even more shocking. This wasn't a 10-year research project finally bearing fruit. This happened months after the October 2023 restrictions. While Western policymakers were congratulating themselves on sealing the technological blockade, Chinese engineers were already in mass production. The assumption that export controls would be effective, the entire foundation of US strategy had just shattered. If China could make 5nm chips without the required technology, what else could they do? What other assumptions were wrong? But SMIC's breakthrough was just the opening move in a much larger game. The ecosystem emerges. While the world fixated on SMIC's chip manufacturing breakthrough, something far more dangerous was happening in the shadows. An entire AI hardware industry was being born. Huawei didn't just make phones with SMIC's chips, they designed their own AI training processors from scratch. The Ascend 9-10B and 9-10C chips built specifically to compete with NVIDIA's band accelerators. And here's where it gets interesting. Performance testing showed these chips approaching NVIDIA a 100 capabilities, not matching them perfectly, but close enough to matter. Then the orders started flooding in. Baidu, China's search giant, placed orders for thousands of Ascend chips. Tencent followed. ByteDance, the company behind TikTok, committed to massive purchases. Alibaba joined the rush. These weren't small pilot programs or experimental deployments. Chinese tech companies were building entire data centers around Huawei's chips. Think about what just happened. 3 years ago, Huawei was a blocked customer desperately trying to buy NVIDIA chips on the black market. Today, they're a supplier with a backlog of orders from the biggest tech companies in China. The ban didn't starve China of AI chips. It created a domestic competitor that will never depend on American suppliers again. But Huawei wasn't alone in this transformation. Baidu developed their own AI processor called Kunlun. They're already on the second generation. ByteDance is building Cloudbang chips. Alibaba has proprietary AI accelerators in development. Every major Chinese tech firm now operates an AI chip division. Not as a side project, as a core business priority with billions in funding. This is the part Western policymakers missed entirely. They thought banning NVIDIA would create scarcity. Instead, it created an industry. You're not looking at one national champion trying to replace American chips. You're watching an entire ecosystem of competing companies, each racing to build better AI hardware, competition driving innovation within China itself. And here's the devastating implication. These companies will never go back to American suppliers. Even if the US lifted every restriction tomorrow, why would Baidu abandon Kunlun chips they spent billions developing? Why would Huawei stop manufacturing Ascend processors that are selling by the thousands? The ban didn't delay China's AI hardware ambitions. It made them permanent and irreversible. But what you've seen so far, the chips being made today, is just the surface. Because China isn't trying to catch up to the West. They're planning to leapfrog it entirely. The long game. China knows something the West hasn't fully grasped yet. Winning today's battle doesn't matter if you lose the war. And they're playing a completely different game. SMIC's deep ultraviolet workaround? It's expensive, inefficient, a temporary solution to get chips into production while something far more ambitious takes shape. Because right now, across China, billions of dollars are pouring into research that could make ASML's $200 million machines obsolete. They're developing particle beam lithography, alternative extreme ultraviolet sources that bypass ASML's patents entirely, advanced DUV techniques that push the physics beyond what anyone thought possible. Companies like Shanghai Microelectronics Equipment are leading the charge. Huawei's chip division has joined the research effort. And the goal isn't to match ASML's technology, it's to build something better and cheaper. Here's why that matters. If China develops lithography technology that costs half as much to operate, they don't just close the gap with Western chip makers, they flip the entire economic model. Suddenly, Chinese AI chips cost less to manufacture than American ones. Not because of lower quality, because of superior technology deployed at scale. The timeline? 5 to 10 years, maybe longer. But China's treating this as an existential priority with unlimited funding. They're not asking if it's possible, they're asking how fast they can make it happen. And while they're building the technology of tomorrow, they're solving a problem most people don't even know exists. You've heard about AI's computational demands, the massive processors, the sophisticated algorithms, but there's a bottleneck that's about to strangle the entire AI revolution: energy. Training GPT-4 consumed as much electricity as a small city for months. That's roughly 175,000 megawatt-hours, enough to power every home in Providence, Rhode Island for an entire year. You heard that right. One AI model used a year's worth of residential electricity for a mid-sized American city, and it's getting worse. The next generation of AI models will require even more power. In the United States and Europe, this is becoming a crisis. Tech companies are fighting for access to electrical grids that can't handle the load. Microsoft's racing to build data centers near power plants. Google's negotiating directly with utilities for guaranteed capacity. Amazon's projects are getting delayed for years waiting for grid connections. Meanwhile, China's building dedicated energy infrastructure for AI. Massive data center complexes are rising in Inner Mongolia, Guizhou, and Gansu provinces. These aren't just buildings with servers. They come with dedicated power plants, advanced cooling systems designed specifically for AI workloads. The Chinese government is planning for over 100 gigawatts of AI computing capacity. That's enough to power several large cities redirected entirely toward artificial intelligence. While Western companies beg utilities for electricity, Chinese AI firms have guaranteed power supply. No waiting lists, no capacity constraints, no competition with residential users. They can train larger models, run more experiments, and operate 24/7 without hitting infrastructure limits. Energy abundance equals AI abundance, and China's building that abundance while the West is still arguing about who gets access to existing grids. But the infrastructure play goes even deeper than power and chips. For decades, China's brightest engineers left for Silicon Valley. They went to work at NVIDIA, AMD, Intel, Qualcomm, TSMC. They learned the secrets of chip design. They mastered AI architecture. They understood manufacturing processes at the deepest levels. The brain drain was real, and it was massive. Now, the flow is reversing. Chinese engineers who spent entire careers in American semiconductor companies are returning home. The Chinese government is offering lucrative incentives, luxury housing in Beijing and Shenzhen, research funding that dwarfs what universities can provide, salaries matching Silicon Valley pay scales in a country where cost of living is half as much. And there's something else driving them back: patriotic appeal. Build China's technological independence. Be part of something historic. These engineers aren't coming home empty-handed. They're bringing institutional knowledge that can't be written in patents or published in papers. They know how NVIDIA's chip teams work. They understand Intel's design philosophy. They've seen TSMC's manufacturing processes from the inside. The knowledge transfer the United States tried to prevent through export controls? It's happening through people instead of products. China is importing Silicon Valley's brain without importing its chips. And then there's the move that could change everything: RISC-V. Most people have never heard of it, but every chip you've ever used, whether in a phone, laptop, or server, runs on an instruction set architecture. That's the fundamental language the processor speaks. For decades, there were only two options: x86, controlled by Intel and AMD, and ARM, licensed from a consortium with heavy US and UK involvement. Even if China manufactured its own chips, they were still using American-controlled architectures. Future sanctions could target those licenses. The US could pull the rug out whenever it wanted. RISC-V changes that equation completely. It's an open-source instruction set, no licensing fees, no corporate control, no government that can ban access, fully customizable for any purpose. Alibaba's T-Head division is leading development of high-performance RISC-V cores. Huawei's adopting it. SMIC's building manufacturing processes around it. Dozens of Chinese chip makers are going all in. China isn't just making chips. They're redefining the foundational architecture to eliminate every single Western dependency. And if RISC-V succeeds, if it becomes the global standard, China won't just be independent. They'll be setting the rules everyone else follows. But here's what makes all of this truly unstoppable: the money behind it. The war chest. The Chinese government and private investors have committed over $150 billion to semiconductor independence. Let that number sink in for a moment. $150 billion. That's more than the entire market value of Intel. You heard that right. China is spending more on chip independence than America's most iconic semiconductor company is worth. Huawei alone is reportedly receiving $30 to $40 billion in government support. SMIC, YMTC, CXMT, each getting tens of billions for fabrication plant expansion. But the money isn't just going to chip manufacturers. It's flowing through the entire supply chain. Chip design software, manufacturing equipment, raw materials, advanced packaging. Every single component needed to build semiconductors from scratch. This isn't venture capital hoping for returns in 5 years. This isn't corporate R&D that gets cut when quarterly earnings disappoint. This is strategic national investment, treating semiconductors like China treated its nuclear weapons program in the 1960s. Unlimited resources, generational timeline. Failure is not an option. American chip companies answer to shareholders. They optimize for profit margins. They face pressure every 3 months to hit earnings targets. Chinese chip makers backed by state funding don't have those constraints. They can operate at a loss for years. They can outspend competitors 10 to 1 on research. They can build excess capacity that would bankrupt a normal company. Because this isn't about business, it's about survival. And here's where it gets truly dangerous for the West. China's playing a game where money is no object, patience is infinite, and the goal isn't profit, it's dominance. But even unlimited capital means nothing if you can't turn it into an actual advantage. Which brings us to the economic flip that could decide the entire AI race. The cost advantage. Connect the pieces you've seen so far. Cheaper chips, once alternative lithography succeeds. Abundant energy at lower cost than Western grids. Labor expenses, a fraction of Silicon Valley's. Government subsidies, eliminating financial pressure. Put it all together, and you get something terrifying. Training frontier AI models could become 50 to 70% cheaper in China than in the United States. Right now, training a GPT-4 equivalent costs over $100 million in compute alone. That's just the electricity and hardware, not the engineers, not the data, not the infrastructure. $100 million for a single model. Now imagine cutting that cost in half. Suddenly, with the same budget, you can train twice as many models, run twice as many experiments, test twice as many hypotheses. The compounding advantage becomes staggering. More experiments mean faster learning curves. More iterations mean better models. The ability to train larger models means breakthrough capabilities your competitors can't match. The country that can train AI the cheapest doesn't just save money. They win the race. Because AI development isn't about having the single best chip or the fastest processor. It's about who can afford to run 10,000 experiments while their rival runs 5,000. It's about who can train the 100 billion parameter model while others are stuck at 50 billion. It's about volume and velocity, not just quality. And here's what makes this so dangerous. We've seen this playbook before. 30 years ago, Western manufacturers said China could never match their quality. Made in China was a punchline: cheap plastic toys and low-grade electronics. Then China undercut everyone on cost. They scaled up production volume. They iterated relentlessly. And within 2 decades, they weren't just matching Western quality, they were exceeding it while still costing half as much. iPhones are assembled in China. Tesla's most advanced factory is in Shanghai. The manufacturing superpower everyone dismissed became the only place capable of building the world's most sophisticated products at scale. Now apply that exact same strategy to AI chips and training infrastructure. The United States is focused on chip performance, speed, efficiency, technical specifications. China's focused on chip economics, cost per chip, energy per teraflop, training runs per dollar. They're optimizing for completely different variables, and China's variables might matter more in the long run. Because if Chinese companies can train state-of-the-art models for $60 million, while American labs spend $120 million, the outcome isn't subtle, it's exponential. Chinese AI labs will outnumber American experiments 5 to 1. They'll iterate faster. They'll discover breakthroughs first. And they'll do it while American companies are still fighting over limited data center capacity and begging Congress for AI subsidies. The cost advantage isn't some future possibility. The infrastructure is being built right now. The energy plants are coming online. The domestic chips are in production. And the economic flip is already beginning. But here's the part that should terrify policymakers in Washington. The strategy designed to stop all of this might have guaranteed it happens. The backfire. October 2023. The United States expands export controls again. They pressure the Netherlands to tighten ASML restrictions. Japan gets pushed to limit equipment sales. The goal: make the blockade airtight. But here's what US officials didn't understand. Before the restrictions, China was content buying NVIDIA chips. Baidu's data centers ran on American processors. Alibaba's AI research used US hardware. The entire Chinese tech industry was integrated into American supply chains, and that integration was leverage. After the restrictions, that leverage evaporated. Now Huawei manufactures Ascend chips by the thousands. Baidu designed Kunlun processors they'll never abandon. SMIC produces 5-nanometer chips without EUV machines. The ecosystem is completely independent of American technology. And here's the devastating irony. If the US lifted every restriction tomorrow, Chinese companies wouldn't go back. Huawei spent $40 billion developing manufacturing capability. These aren't sunk costs, they're strategic assets that make China independent forever. The ban didn't create a temporary setback. It created permanent competitors, immune to all future pressure. But the backfire goes deeper. Before restrictions, Chinese chip development was fragmented. Different companies pursuing different approaches. Debate and disagreement slowing progress. The US export controls unified them instantly. Suddenly, every Chinese tech company had the same enemy and the same goal. The restrictions turned semiconductor independence from a nice-to-have into an existential crusade backed by unlimited funding. America didn't just create competitors. They weaponized an entire nation's industrial policy against themselves. And now the question haunting Washington: did the US slow China by 2 years? Or ensure that in 10 years, China controls the entire AI hardware stack, while America has lost all leverage permanently? But there's one final truth that reveals just how completely the script is flipped. The future nobody saw coming. That Huawei phone that appeared in August 2023 wasn't just a product launch, it was a message. And the message was simple: you can't stop us anymore. Think about what China has built in just 3 years. A complete AI chip ecosystem with multiple competing manufacturers. Energy infrastructure capable of powering 100 gigawatts of AI computing. Domestic lithography technology that bypasses the ASML monopoly. Talent pipelines pulling Silicon Valley's best engineers back to Beijing. An open source architecture in RISC-V that eliminates every Western dependency. And financial backing so deep that failure isn't even a consideration. The United States spent $150 billion, the GDP of an entire nation, trying to strangle China's semiconductor industry. And China responded by building something the US can never sanction, never restrict, and never control again. But here's what should terrify anyone paying attention. China isn't trying to catch up anymore. They're positioning to leapfrog the West entirely. When alternative lithography succeeds, Chinese chips won't just match Western performance, they'll cost half as much to produce. When the energy infrastructure comes fully online, China will train AI models at scale no American company can match. When the cost advantage kicks in, Chinese AI labs will run 10 experiments for every one the US runs. The AI race everyone thought was about who builds the best algorithm? It was never about algorithms. It's about who can train the most models, the fastest, at the lowest cost. And China just built the infrastructure to win that race. The ban that was supposed to protect American AI dominance did the opposite. It guaranteed China would build an independent AI hardware empire. It ensured they'd never depend on US technology again. It created the exact competitor America feared most, one that's completely self-sufficient, economically advantaged, and utterly immune to sanctions. America built walls to contain China, but those walls became China's fortress. And now the question isn't whether China can compete in AI hardware. The question is whether the United States can compete when China controls the energy, the chips, the architecture, the talent, and the cost structure. When every advantage America thought it had has been systematically neutralized. That phone wasn't just a warning. It was proof that the AI hardware race already changed, and most people still don't realize what it means.